All right, welcome back. I hope you're having an amazing time so far. Our next speaker is Christoph Aubry. He is the head of sales and sector strategy at Expert.ai. Please join me in welcoming him to our virtual stage.
Thank you, Patricia. And hi, everyone, and welcome to this session. My name is Christoph Aubry. I'm the head of sector strategy at Expert.ai, and I have a long-term experience serving information providers, healthcare, and other industries. Expert.ai is the premier artificial intelligence platform for language understanding. We are specialized in building software solutions based on our patented NLP technology. What I'd like to do today is to introduce you to some of these solutions and how we build them to reach targeted returns on investment. So in 30 years, we have been deploying numerous applications. They gradually required we embed more and more knowledge to support the needs of our clients. I'm illustrating here a variety of business needs that we address for different domains. For instance, document classification for media, customer interaction in finance, or knowledge discovery more recently in pharma. As the technology evolved, we have been able to regularly raise the levels of accuracy, process automation, and user interaction in our applications. Our abilities grow with the knowledge we can structure, acquire, and also standardize for each of the applications that we are building. We rely on our platform that has the ability to imitate the way humans read and understand content. Some applications fall in the category of AI machine intelligence now because we bring some self-learning capabilities, for instance, looking at new concepts or learn from user feedback. When we started 20 years ago, we released our first knowledge graph to capitalize on general knowledge in one language. Today, we support multiple languages, also specialized our graph in different business areas. I think what we've seen equally that applications that we built using AI, starting with being worker-centric, today they are really network-centric solutions. So more users are involved. Language powers business. If you are, for instance, an insurer or a bank, the language in an insurance policy or mortgage contains the contractual commitments you and your customer make to each other. If you are working for a pharma company, the language in medical notes in scientific articles or patents contain medical insights. That's what will drive drug development or potentially break a new treatment. And the language in news articles, analyst reports, press releases that are delivered by information providers contain the business insights you need to make a smarter business decision. The same applies to other industries with applications such as voice of customers, for instance. In fact, every critical business process from medical research to customer interaction today revolves around language. But language, as much as a critical type of data, is difficult to handle. So far, in any business process that involves language, humans have been front and center, searching for the right document, assembling data from different sources, updating data, and so on is very time-consuming. The impact that scaling the process has been very difficult. So document handling is resource intensive, adding more resources is also often a challenge, and the expertise is acquired slowly and is unevenly distributed. All of that is because language has been difficult for technology to handle so far. Words are not numbers. Machines struggle to understand the meaning of documents, and this is especially the case when domain knowledge is so critical to understand specialized content. Let me share with you some examples. As you can see here, language is difficult to understand, but because it's ambiguous. So we had to deal with the ambiguity since the first day when we started working on natural language processing. So in those examples, is Wall Street the district or the financial markets? If you look at the iris, is it the plant or is it the membrane of the eye? Is the fisherman handling financials or gone fishing? And so on. There are numerous examples of that kind. So one way to address the ambiguity issue is to rely on a knowledge graph. And this is what we have been doing for years to precisely identify key information from unstructured content. The graph contains the meaning of words and also the semantic relationship between concepts. It reflects the richness of how knowledge is structured. The depth of the graph allows for understanding ambiguities and also to create variable application. The graph is really extended. Here we show an extension more in the healthcare industry, because that's we leverage already different standards and also normalize information. Our natural language platform relies on what we call a hybrid approach to AI that is applied to language data. It consists of the combination of both natural language understanding and machine learning. To go one step further, it also involves any existing taxonomies for data normalization purposes, but also knowledge graph to manage language ambiguities. The goal is to offer best of breed functionalities to mimic the human-like comprehension of content. So as you combine the different techniques, you need a platform to be able to streamline the integration and use of these different technologies into the same workflow. Our goal is to deliver high accuracy when dealing with scalability needs. Also, the platform is open to subject matter experts to capitalize on domain knowledge via dedicated authoring tools. This allows for human interaction with the platform, but also at the production level when it comes to provide some feedback to the technology in order to train and to learn better on the expert knowledge. Let me share some examples. I will start with the knowledge discovery. Most of the organizations, from asset management firms to media companies to health research centers, are dealing with an incredible high amount of documents, articles, digital assets, and so on. In the life science field, according to Nature, the global scientific output doubles every 9 years, which was verified since the discovery of the human genome. So our goal is to support these organizations in making the right decision before investing in product development. To adapt from one industry to the other, we built mechanisms to understand specialized domains, collect information, and also assemble knowledge. So what is knowledge discovery? That's the process of building what we call actionable intelligence, information you can leverage to support decision making. In the case I will be illustrating today, we extract and structure information on company events such as nominations to a role, acquisition of other businesses, public communications, and so on. The goal is to build competitive intelligence landscape for a specific area of interest. We start by analyzing tons of financial reports, news stories, press releases, to name a few. We then extract information about how companies evolve, who they hire, when and for what role, who are the shareholders, how many shares do they own, what businesses they acquire, when and for how much, and so on and so forth. So after we collect content from various sources, we can run it through our analysis engine for pre-tagging and data extraction. The system is already able to retrieve a lot of information without having the requirement of any pre-training. One can then navigate within the documents, review the information automatically extracted, add more data types, and also prepare for training sets for data modeling purposes for information that is not yet retrieved, or depending on the domain of interest. What you see here is a very easy to use interface for subject matter experts to analyze content, define their data structure, and label information. One of the outcomes is that as soon as we process the data according to different language models that we design, you ultimately feed a knowledge repository. That's particularly the case when we train the platform to look for company events such as acquisitions here. Information is usually spread on multiple pages of a financial report or across multiple documents. Data is then collected as the system reads through the content. By standardizing the entities extracted or the connection between them, as you can see here, we gradually build an accurate knowledge graph that will support further applications. The entities can be people names, organizations, countries, dates, products, etc. And the relations we connect are the interaction between these entities, such as an acquisition or a nomination to a job function. Ultimately, the result of this process, done in a fraction of time compared to a manual analysis, is a competitive intelligence landscape about an industry or domain. Users can navigate within the knowledge base or directly access dashboards that are updated in real time according to the flow of data that is coming in. This way, any announcement in the industry is monitored and any changes in the company structure can be tracked over time. And people can directly get alerts on these changes so that they receive only information that matter for them. The system will monitor for them. So that benefits to decision makers. Going for another example, let's look at what we call this medication challenge. Totally different industry. Here, that's an interesting challenge that has often been met by health providers, but also health insurances or pharma organizations. It revolves around the processing of medical notes for the purpose of knowledge discovery, claim processing, or fraud detection. A hospital is, for instance, looking at streamlining the invoicing of the services delivered to patients. A health insurance will try to prevent fraud, distinguishing what is past medical history from accident-related injuries, for instance. So we work on hundreds of discharge summaries courtesy of the Harvard Medical School. So here's an example of how natural language processing works. In this sentence taken from a medical note, we recognize various entities such as demographics, conditions, and symptoms. We also link them to standard terms in nomenclature when possible. Then we identify relationships between these entities such as observation or treatment. We also take care of weighting the relationship based on the degree of assertion in the language. Is it a potential treatment? Is it a potential involvement, or is it a real symptom triggered by a drug? So ultimately, the process helps creating structured data from the discharge summaries. That's the facet that you see here. We not only create metadata, but information is also normalized with existing nomenclatures and standards. For instance, shortness of breath will be tagged as dyspnea as the standardized term for this symptom. One of the outcomes is the ability to index medical notes from different point of views. This enables search engine with facile navigation. That's one example that we see here, and also prepare for further data analytics. An example of data analytics is how we leverage our ability to identify relationships between patient factors, such as the age range, for instance, and diseases or symptoms. These relations are identified thanks to linguistic capabilities, not leveraging statistical analysis such as co-occurrences. So we really rely on real connections that have been evidenced in different publications or medical notes. Here's a summary of the main symptoms observed in patients as indicated in this discharge summaries. They are linked to the drug that are likely to be the cause of these symptoms for these patients. Each time, experts have access to the evidence in the medical notes that led to this conclusion. So you always make sure that you have explainability in the process. The same type of analysis is available for other types of relationships, such as the treatment of a disease by a drug. Let me now switch to another example for potentially different industries. We live in a world brimming with information. We all realize that. So the digital universe is growing exponentially every year, and the data available to us far exceeds our ability to process it. It then becomes outdated and irrelevant. So how many people look at abstracts and summaries instead of looking at the full text article? So you look at the full text, so you look at the full news stories as soon as you are captured by the main elements that you can find in the summary. You don't go through the whole article itself ultimately initially. So in order to help us accessing information essentials, we work on approaches to summarize long pieces of content to a shorter version. So these smart summaries are aimed at capturing the most relevant data from a bill, a regulation, a news story, or a scientific article. Our approach combines different AI techniques that prove to be relevant to extract key elements from documents. We validated the approach on federal and state regulatory documents with the goal to expand to all state sources and various domains, health and others. NLP and machine learning are used to retrieve name entities, dates, bill numbers, or administrative information, but also identify document types or capture the most relevant sentences. Ultimately, the goal is to enable subject matter experts with a tool that speeds up the review of source publication and shorten the time to publish smart summaries. So here's an example of a multi-pages long federal health regulation on the left and the one-page summary on the right. Experts remain in control of the summary, but benefit from significant efficiency gains. This is definitely a very promising ROI that we have seen that is bringing additional benefits. First of all, the extracted data become part of the enterprise knowledge. Secondly, the time saved by subject matter experts to summarize information can be dedicated to the creation of new products that will lead ultimately to new offerings and new revenue generation goals. So let's switch again to another domain. Try to give you a sense of different applications of what we call explainable AI. Risk assessment. In over the last 5 years, we faced an increasing demand coming from financial organizations and insurance companies. Insurance subscribers are aware of on-demand and looked for flexible cover. There's a shift in attitudes. Combined with the adoption of new technologies, insurers are pushed by the need to modernize and remain competitive. At the same time, insurance is fighting with emerging risk exposures such as pandemic, cybersecurity, potential uncertainties, and so on. Policies must also be accurately reviewed to limit the exposure to more risk. So the challenges are multiple from a risk management standpoint. So let's look at an application to contract analysis. Here's an example of application implemented for commercial insurers to efficiently review group policies that are issued. The reason for such application are threefold. First of all, there are many misalignments in coverage, limits, exclusion, or endorsement between a master policy and local policies. So there's a risk of having misalignment here that needs to be prevented. There's a high volume of policies and the documents are very dense. Secondly, underwriters cannot also handle high volume of policy reviews as process is very time consuming. The policy is written by different people with different skills and knowledge. Once issued, local policies are binding with unintended deviations exposing risks and subsequent losses. So ultimately, the process we design is very fast, consistent, and offers to cover 100% of the policy issues. Still, experts can have access to the review, can look at a summary of the different potential alignments or misalignments, and can make a decision to act on corrections. Behind the scene, the knowledge required to compare policies is very deep about the languages covered and the domain itself. You need to understand what is a policy. You need to understand the domain or the type of coverage that is supported by the insurance carrier. So the system always comes back to the original document. It all helps underwriters finding the reasons for any discrepancy that have been identified. So after these 4 different types of applications, and again, there are many others, but at least you see how technology can be leveraged in different business areas. Let me summarize with some takeaways. There are various keys to success in this hybrid approach to building knowledgeable applications, explainable applications. First of all, the identification of relevant data sources makes sure that you have access to any useful input, the news, financial information, financial reports, publications, agreements, whatsoever. Create also access to an integrated and standardized data set so that it helps selecting the raw data you need for your analysis. The normalization of extracted data is also very important thanks to standards or in-house taxonomies. Then building a data repository to capture this knowledge is really a basis for what we call knowledge discovery on most of the applications that we design. Here are the main benefits we observed and validated with users. A knowledge synthesis dashboard is easy to use and interact with. There are time savings. Expert is reviewing insights rather than compiling, reading through thousands of articles. It's dynamic. Information is regularly updated as new documents are processed, and the knowledge augments over time. The last element is data transparency. It's very key to bring explainable results. Users can validate results and they have direct access to evidences. Last, what matters is the combination of technology with subject matter expertise. Expertise is critical to design such approach and validate the information provided is accurate. The combination of flexible AI approaches, leveraging the strengths of NLP, machine learning, together with domain expertise is the ultimate benefit to anticipate users' expectation and provide actionable insights. I always feel very good to be inspired by visionaries and influencers, especially when their quotes still resonate in our modern world. So Daniel Boorstin was historian and librarian for the Library of Congress. Translating in our digital world, I think his quote highlights the need to capitalize on human knowledge in a way that is applicable and trustful for the AI-based application that we are building today. Thank you for your attention.
Amazing, Christophe. Thank you so much for sharing. We really appreciate these insights. And I know this virtual audience is giving you a huge virtual round of applause. Thank you for sharing with us today. For the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our amazing exhibits. Thanks so much, and we'll see you around.
Thank you.